Ladies and gentlemen, please welcome on stage Bhupesh Lall, Senior Director Marketing, Autodesk APAC in Japan. And he'll be speaking on the future of design and manufacturing.
Good morning, Bangalore. Good morning. Thank you, Kamal and Naveen, first of all, for sharing your absolutely amazing story. It's inspiring to hear how Total Environment is transforming their business through technology and going through a digital disruption in a sense. And that's exactly what the manufacturing industry is also going through. And I'm here to talk to you about how the manufacturing industry is being transformed, how global trends are impacting manufacturers worldwide, and how we at Autodesk are partnering with each one of you, our customers, to make sure that we all thrive in this digital transformation. So you heard Harish talk a little bit about macro trends that are shaping the industry and that are shaping the future of making. He spoke about the need to do more with less and the opportunity to do better. For manufacturing companies, the need for better is being driven by a number of different factors. First of all, the products that we design and make every day are getting much more complex. There's much more electronics, there's sensors, there's new materials that are present in all the products that you're designing and making every day. There's much more competition in your areas. Manufacturers need to have the ability to deliver new and improved features and functionalities in a much more agile way. And on top of this, your customers are getting much more sophisticated. They're much more demanding. They're looking at personalized products to meet their individual needs. The good news in all of this is that there are new means of production that are showing immense promise, and these will help you do more with less. Now, there are new advanced manufacturing methods. Couple that with automation that are opening up amazing possibilities for manufacturers like you to increase productivity and to innovate much faster. But the challenge is that these new technologies require a new process, a new way of working, and new tools to drive them. The fact is also today, the tools that most of us use in our jobs to design and manufacture products are generally disconnected from each other. They use very different data formats. They have completely different user experiences that all of you experience every day. And they require typically all of you as users to manually translate, manually transfer, and often recreate data in different formats. I hate to say this on main stage, but it's a bit of a mess. The result of this mess on productivity for every individual is astounding. The average design engineer wastes about 1/3 of their time on non-value-added activities, like dealing with incompatible file formats, transcribing notes, recording, sometimes even re-recording their comments on PLM systems. Now, the opportunity for better for manufacturers is not only about making products better, but it'll come by making your processes better. It'll come by making work better. And it's really the opportunity to make your own lives better with the right tools and the right technology and the right processes. This need for better drives customers to look for next-generation efficiencies. So the video here that you're seeing is the world's largest telescope. Now, this has more than 1 million components. Imagine the inefficiencies of designing something like this with a messy set of tools and processes. You can all appreciate the obvious need and cost to get it right the first time. We're very proud one of our customers, Dynamic Structures, solved that problem by using Autodesk software to design, manage, and install this amazing piece of technology. Let me give you another example. The need for better is driving companies like Claudius Peters to do things differently. You heard about them in Harish's keynote. Claudius Peters, again, as a reminder, they manufacture material handling equipment. They're exploring new design and engineering workflows to improve product performance. Like in this case, this generatively designed, much lighter clinker cooler that you see. Now, this design costs much less to manufacture, is more efficient, and as a result, has less negative impact on the environment. But the opportunity for better at Claudius Peters extends beyond just a single exercise in lightweighting. Claudius Peters, again, is a 100-year-old company. And for most of their history, they've relied on traditional design and manufacturing techniques. They've come to the realization that in order to, in the words of their own chief digital officer, avoid going extinct like a dinosaur, they need to evolve and they need to get on a journey. So they've started the whole process of digital transformation. Again, Thomas Nagel, their chief digital officer, has put initiatives in place that he calls inspired excellence. And they're focusing on 4 major things that I'd like each one of you to reflect on in the context of your own businesses, your own work. It's about improving product quality. It's about reducing the lead times, reducing costs, and increasing customer satisfaction. One of the key ways that Claudius Peters is realizing these opportunities is through Autodesk's collections. So with the product design and manufacturing collection from Autodesk, Claudius Peters has access to tools that help them streamline that data, that unite teams for better collaboration, and automate processes across disciplines, connecting their 3D models with detailed component designs. At the heart of the collection is Inventor. What you see here is Inventor on subscription. This is Inventor 2020. And it's by far the fastest, most capable Inventor that we've ever delivered. Now, I recently met a customer who actually opened up a 2.5 million component assembly on his desktop. That's a gigantic model. Only a few years ago, that would have needed a humongous amount of compute resources to just open. And he was doing it with such ease at a trade show. But it's not just performance. We're also investing in the entire experience that you get with Inventor. We're delivering the ability to model more complex parts, the ability to unfold complex sheet metal, streamline frame generator workflows, and much more. Much more like tolerance analysis. And I know this is very important to most of you. This is an example of how connecting manufacturing knowledge and data to the design process can help you make better decisions faster. In product design, as you all know, the higher the tolerance, the more expensive it is to make the product. With the new tolerance analysis tool available, engineers now have the ability to optimally balance manufacturing quality and cost before a single part is cut. The collection is also about making connections. It's about connecting design to manufacturing. And for many of you who need to use your products in the context of buildings, it's also about connecting detailed mechanical designs to BIM models. Now, here's an example that shows how Inventor and Revit work together, they come together. Now, you're able to connect detailed mechanical models of building components with the building model itself, with the BIM model. In this video, you're seeing a balcony being created in Revit. It's brought directly into Inventor, where it's being edited. Details get added for the fabrication that are required. And once this process is completed, the changes are passed from Inventor back to Revit with the appropriate amount of detail for the building model. It's really cool how these two products work together and make your workflows much easier. With these additions, Inventor 2020 is quite simply the best Inventor ever. And not to forget, with the collection, customers are getting all the goodness of Inventor, which is fully connected to the world's best 2D design and documentation tool, which I know a lot of you use, AutoCAD. As you would expect, when you update your AutoCAD model, the Inventor model gets updated, and vice versa, when you change things on the Inventor model, the AutoCAD model gets updated as well. So it makes life easier. It makes the process much more smoother and easier. Add to that, within the industry collection, there's Navisworks, there's reality captures, there's visualization with 3ds Max, there's factory planning, there's layout tools, and of course, everything here that you see is tied together through Vault to manage your product data. Through the collection, we built a number of workflows that are directly connected to Inventor. Now, we've added simulation, we've added CAM, we've added nesting. I want you to take a look at this video that I'll play shortly. It's a company called Matsuura Machinery Corporation. They're a Japanese machine tool manufacturing company. And it shows a typical production manufacturing process. You will recognize this customer is using 5-axis strategies. The workpiece holder is generatively designed and hybrid manufactured. Now, just by doing that, Matsuura was able to cut the time to produce the workpiece holder from weeks to days. And by the way, that's going to be a very common theme you're going to hear in all presentations. And it was also able to reduce the number of parts, and all of this without any increase to the cost. You see a combination of several technologies here: generative design, 5-axis machining strategies. The good news is when you take the industry collections, it comes with Fusion, and you get access to all of these technologies. It's really amazing. And by the way, this is the same generative design technology that Claudius Peter used on their clinker cooler project. Fusion 360 is in the collection, and it directly connects with Inventor. Fusion helps you go beyond traditional workflows and helps combine those new breakthrough workflows with your deep engineering practice that you're already deploying using Inventor. So let's take a look at how we do that. You can take an absolutely fully engineered model in Inventor and leverage it in Fusion to run a generative design exploration study. Take a look at this component from the front assembly of the wheel. You start by using well-known design tools like stretch, extrude, and so on. You still have precise control to define areas that you want to preserve that are shown in green and areas that you want to avoid that are shown in red here. Now, this lets you build the design space for generative to explore while maintaining the assembly tolerances needed to produce viable results. But that's not all that we're considering. The generative design process is also informed by material. It's also informed by performance requirements like factor of safety. It's also informed by structural constraints and what loads you're going to put on the product, on the component. And of course, the manufacturing process that you want to deploy. So if you have several material options and you want to explore a few loading conditions, you want to apply different manufacturing processes, generative design augments the design scope and helps provide hundreds of results. This isn't just optimization. This isn't just improving an existing idea. These are new ideas that the tool generates for you, and that puts the power of design, that puts the power to design an absolutely valid and manufacturable component into the hands of every engineer, every designer. Now, over the last year or so, we've been delivering advanced manufacturing capabilities, which includes a combination of processes like die casting, multi-axis milling, 2-axis cutting, and of course, additive as well. There were customers like Claudius Peters, who used the generative results from Fusion 360 and redesigned their products to fit the conventional manufacturing methods that were already being deployed. The good part, again, is we have results now, which we can use to compare a part that was designed manually to a part that was designed using generative. Now, generative, no surprises, achieved an exact factor of safety target of 3. That's exactly the value that we were looking for. The manual design part actually ends up being over-engineered. It's heavy, which means there's more material on it, more cost, and you know the rest of the story. But by how much is it heavier? The 3-axis generative result is less than half the mass of the human design. But the other difference is also in the time to manufacture. So at the end, you get a solution that is optimized for multiple dimensions, not just cost, not just time, but multiple dimensions, including manufacturing processes. You get some pretty interesting results to compare, and each result comes with a cost range and a median. It's not just 6 results. It's literally hundreds that you get to make trade-offs from, that you get to choose from. You're armed with engineering information, but we realize that's not the only thing that matters. Enrich these results now with even more data, including cost. And the numbers, by the way, are not something that you need to calculate. It's the system that is generating these numbers for you, including the cost, which is pretty amazing. Now, this is the cost for all of those options visualized on a scatter plot. You can now compare cost just like any other engineering properties. See how easy it is for you as engineers to make the best decision for your business now. Net-net, this is democratizing design with new accessible constraints and enriching with cost to help you make practical and much more profitable decisions for your companies. After this, once you've made the decision on which design to go with the optimal cost, optimal factors, you want to manufacture those parts efficiently. So therefore, we're also continuing to develop Fusion's manufacturing tools. Let me walk you through a little bit here. These extensions in the Fusion product give you access to some of these manufacturing tools immediately when you need them. Features like steep and shallow from PowerMill, hole recognition, in-process inspection that helps to generate high-quality parts with limited human intervention, as well as, of course, additive, which is becoming much more popular, where the real power is a fully hybrid manufacturing environment. Now, these extensions enable you to get access to these technologies in a very simplified way. You can either get them on a pay-per-use, a pay-per-quarter, a pay-per-year model, so it makes it very affordable, very easy to buy and use some of these products. And all of this comes with Fusion, by the way, as a part of Inventor in the industry collection. Now, in addition to integrating mechanical design, simulation, and connectivity with BIM, and giving you access to generative design, costing, and advanced manufacturing, we're making it much easier to connect your engineering team with the rest of your business for better collaboration across the different departments in your company. The new Vault Fusion Lifecycle Connector makes that really simple. It makes it simple to manage your design data, your engineering processes from one centralized location. And to extend the value of your data even further, we continue to build on the Forge cloud developer platform. Now, here's an example of a partner like Moicon. They're using Forge technology to reimagine how we design and manage factories. Now, Moicon is transforming the factory floor by offering insights into operations, by optimizing performance, and reducing downtime. They're using Forge to create digital twins of factories and, of course, facilities. And they do that by connecting 3D models. They're connecting them with process simulation, with documentation data, with instructions, with maintenance cycles, facility management information, IoT sensor data. It's all coming together. It's all of this data that comes together in dynamic 3D representation of factory floors. Again, Forge, Vault, the collections, Fusion are all connecting data, processes, and people. At Autodesk, our mission is to make you and your customers' lives better by connecting design to manufacturing. We're connecting data and processes and helping break down silos. Silos between people in different departments, silos between machines, and frankly, silos between machines and people. It starts by putting data at the center of the process, by establishing a unified product definition that connects everyone at every stage of the process. That means connecting industrial design, mechanical engineering, electronics, simulation, and manufacturing. With generative design, we're connecting designers and engineers, making it much easier for them to quickly explore valid design options with the confidence that the results will be viable for production. Putting data at the center of the process makes it possible to connect design to production, to connect people and machines, to intelligently monitor production, connecting the top floor to the shop floor. Putting the data at the center makes it possible to connect people inside your company, to collaborators and others outside of your company. Your partners, your suppliers, your customers, they get much more connected into the work that you are doing. This, ladies and gentlemen, is the convergence of design and manufacturing, and this is the future of making. Thank you, everyone. Enjoy the rest of AU.
Thank you, Bhupesh.